This is a practical exercise to accompany my lectures on statistics for nuclear medicine. You should be able to do it after listening to the first and second of my lectures. In this experiment we're going to do an exercise with some dice. To collect the data, you will see a video of an experiment throwing 72 dice. There are going to be 9 separate throws, and all you've got to do is to count the number of sixes thrown each time. So you'll need to get a pencil and paper so that you can record the results. If you haven't got one handy, pause this video and continue when you've got something to write with. Okay, are you ready to proceed? Let's watch the video. Here we're throwing 72 dice into a tray, and you can see there are quite a few sixes. To make life easy for you, we've magically removed all those dice that aren't sixes, so all you've got to do is just count the sixes. There's no need to rush. The video will stay there long enough for you to count them. Here's the second throw. Once again, we've removed the ones that aren't sixes, so you can just count the ones left. Here's the third throw. And the fourth throw. If you have difficulty writing things down, just pause the video or rewind it to give yourself a chance to review each throw. Throw 5. Throw 6. Throw 7. Throw 8. And throw 9. If you didn't manage to get down all of the numbers, just go back to the beginning of the video recording using the table of contents on the left and watch it again. Hopefully you found that the number of sixes in each throw was 14, then 13, then 8, 9, 16, 18, 10, 7 and 10. If you didn't get that, just go back and check with the video once more. Now that you've got the data, I'd like you to think about the answer to these questions. First of all, how many sixes per throw would you expect on average when you throw 72 dice? Secondly, can you calculate the mean number of sixes per throw that you actually obtained in this experiment? Thirdly, what standard deviation would you expect for the number of sixes from 72 dice? And finally, can you calculate the standard deviation of the number of sixes that were actually obtained in this experiment? I don't mind how you try to do that calculation, whether you do it manually, as I've shown you in these lectures, whether you do it in an Excel spreadsheet or whether you put the numbers into your favourite statistics program, either on your computer or online. But I do hope that one way or another you'll have a go at doing it to give yourself a bit of practice at these calculations. If you get stuck, or if you want to check whether your answer is right, then you'll find a model answer in another of these lectures.